Okay, let's get started. We are going to learn about the laws of sines and the laws of cosines. And typically with trigonometry using sine, cosine, and tangent, we needed right triangles. Well, what's cool about the laws of sines and cosines is you don't need right triangles at all. So there are two situations where we're going to use the law of sines, and there's going to be two situations where we use the law of cosines, and it's really based upon what's given to you. So where it says number one here, when we know two angles and one side, we're going to be using the law of sines. When we're given a side and the non-included angle, then we're going to use the law of sines as well, but we have different cases for those situations. There's like 6 cases altogether. We'll explain that later on. And then for the law of sines in here, law of cosines, when we're given all 3 sides, that's when we're going to be using the law of cosines. And then in the situation where we're given side, where A is the included angle, we're going to be using the law of cosines as well. So I've mentioned just now included versus non-included. That has to do with the order of the letters. So if you just look right here, angle, side, for example, the side is what we consider non-included. If I have angle, the side here is included. All right, so be sensitive to the order of the given information. Another thing to be on the lookout for is the upper and lower cases of the variables we're going to be using. So take note here, anytime we have a vertice, we have capital letters, and if you look across, that's where going to be the lower script letters are going to be located. So if you look across from C, for example, we have little c. If you look across from capital B, you have little b. And the same applies for really any set of letters. Now, we're going to be using with A, B, and C for quite a while, but we can use any letters like you see here, D, R, and P, and if you look across, that's always the lower script letter. So, what are the laws in cosines? It is a bunch of formulas. So, hit pause right now and copy down the law of sines, and here it's basically these 3 ratios equal to one another, so it creates this large proportion. And the law of cosines, it looks like there's 3 different equations in here, but as you'll develop more experience, it's really the same exact equation. We're just isolating a different variable. And once again, here's that little diagram representing capital letters and small case letters and where they go. There are some alternative formulas to the law of cosines, and here they are. This is the alternative set, and I like to use that when side is given. And when side is given to us, I like to use the regular formula. Again, hit pause, copy those formulas down. We're going to be using those soon. You'll hear this phrase, solve for the triangle. And when we say solve for the triangle, that's basically saying, hey, find all the angles and find all the sides. Notice there's 3 angles and 3 sides. So you're going to be given some of this information. You have to find the rest of it. All right, let's do an example in here. Let's go right here. This is our first example. So the goal is to solve for the triangle, and this is information that we have about this triangle. So it's important to draw a picture so you can fill in some information. In this case, I see a capital C, I see a capital B, and I can use any other letter I want. I'm going to use A in this case to represent my 3 vertices. And it's telling me C is 102, capital B is 29, and little b is 27. Well, if little b is 27, that's across from the 29. It's going to be right there. So notice I didn't draw the picture to scale. It's really not going to matter. In fact, and sometimes when you're given information, it's really challenging to draw it to scale since we don't have enough information to draw it properly to scale. So I don't get caught up on drawing it to scale or not. I just slap down a triangle, I put in the given information, and now since we are given 2 angles, we're going to use the law of sines. All right, and what does the law of sines look like? Well, it's the sine of A all over little a, and it's the sine of B all over little b, and it's the sine of c all over little c. So notice we know a lot of this information. We know capital B, we know capital C, and we also know a quick way to get capital A. Since it's the angle sum theorem, and we know two angles inside of a triangle, if I add those two other angles up and subtract from 180, this angle turns out to be exactly 49. So notice I know all three angles now in this triangle. And if you notice, there's three ratios. Well, we can't use all three at the same time. We can only use two of them at the same time. Well, which two do I use? At this point, you want to be looking for, what letter do I know everything about? Well, I know everything about B. So if I fill that in, I'm going to go the sine of 29 all over 27. And now I have a choice. Since I don't know little a, and I don't know little c, I have to pick one of these, and it doesn't matter which order we do. I have to solve for little a first or little c first. It doesn't really matter. I'm going to do little a. So I'm going to put the sine of 49, because that's what capital A is, all over little a. Notice at this point, this is great news. We have a proportion. We have two equal ratios, and we're going to cross multiply and solve for a. So hopefully you can take out your calculator and go the sine of 49 times 27 divided by the sine of 29, and I'm getting 42.0312. And to find C, I'm going to use that same exact ratio. Since I know everything about B, I'm going to go the sine of 29 all over 27 is equal to the sine of C, which is 102, divided by little c. Again, I'm going to cross multiply and solve for c. I'm getting my calculator out right now, and this is going to be sine of 102 times 27 divided by the sine of 29. So in this case, I got little c to be 54.4749. All right, well, that's our first example. I'm going to stop the video now and create another one with a few more examples using the law of sines.